Today we will study a little more detail about a very special class of dyes called the Vat dyes. I had mentioned fleetingly when we were doing different types of dyes, structurally different types of dyes, as indigo being one of the Vat dyes. Today we will try to look at the process by which this Vat dye is actually fermented and used. What are the different parameters for dyeing with Vat dye, and so on and so forth. You will realize that this particular type of dye needs really some special attention, for the simple reason that Vat dyes are very popularly used in the industry. Secondly, they have a special kind of processing, unlike the direct dyes and the reactive dyes and the dispersed dyes and so on and so forth, or even the natural dyes. So, whether we take an example of a Vat dye which is of synthetic origin or a Vat dye which is of natural origin, they all go through the similar process of oxidation, reduction, and therefore, we will talk more in details about the Vat dye. Vat dye, any of a large class of water insoluble dyes such as indigo and the anthraquinone derivatives that are used particularly for non-cellulosic or cellulosic fiber, that is particularly water insoluble. Vat dye, when we talk in terms of its being water insoluble. Now, if a dye is insoluble, how does it actually get adhered to the fabric? Because so far we have been learning about one fact, that the dye should be soluble in water or at least in 50% methanol water. Then only the dyeing, it fits into the category of being a dye. But here is a dye under the class of Vat dye which is insoluble, but still it is applied, and it is a large class of dye which is being used in the industry. The dye is applied in a soluble reduced form to impregnate the fiber and then oxidize in the fiber back to its original insoluble form. So, it goes through a process in which it solubilizes for a while, gets into the fiber, and then when the fabric is taken out, it is back to its insoluble form. So, that is how this beautiful Vat class of dyes are used in industry as well as in a laboratory, because if this oxidation reduction and this insolubility, insolubility was not functioning accordingly, the Vat dye would not have been in use. Vat dyes are specially fast to light and washing. So, they have a very big advantage, although they have a disadvantage of being insoluble, but there is a way to solubilize it and impregnate on the fiber, and therefore, because it has very good light and wash fastness, it really fits into the best category of dyes. So, if we try to weigh the advantages and the disadvantages, the advantages are far more than the disadvantages. Brilliant colors can be obtained in most shades. So, it is not that Vat dye is only associated with indigo and indigo is blue. It could have a variety of color, and they are very bright, brilliant color. They are not dull colors. Originated in medieval Europe, Vat dyes were so named because of the vat used in the reduction of the indigo plants through fermentation. So, because the vessel that was used was a vat vessel, that is why the name came to be as Vat dye. Otherwise, this has its own way of, it can be carried out in any type of vessel, but because of the earlier times the name has persisted. What are Vat dyes? Vat dyes are most important dyes for dyeing and printing on cotton and cellulosic fiber. So, it is, as I told you, that when we were talking about natural dyes, I told you the toughest of the tough is the dyeing of cotton. Silk and wool, being from the proteinaceous nature, can take up natural dye very easily. And I also mentioned that for dyeing cotton, many pre-treatments like treatment with tannic acid and of course mordanting and all that is required only for the dye to be able to adhere. And here is a dye, vat dye, which does not require mordanting and is best suited for cotton or cellulosic fiber. So, another advantage that comes on the side of the vat dyes is that it is very good for the toughest material, that is the cellulosic fiber. They have excellent all round fastness, which includes washing, light, perspiration, chlorine and rubbing fastness. So, it is not only just the light and wash fastness, it has an overall or all round fastness. It is one up from the other dyes. So, therefore, it is very good washing fastness, light fastness, rubbing fastness, perspiration fastness and even chlorine reaction, because sometimes chlorinated water is obtained from the municipal corporation, and so if the dye is reactive towards the chlorine, it will fade off, but it is able to sustain even such chlorinated water. Nobody treats chlorine on the fabric directly, but it is the chlorinated water sometime from the supply which can create fading in many cases, but vat dyes are resistant to it. Vat dyes are insoluble in water and have to be dissolved in water by using sodium hydroxide and sodium hydrogen sulphide, usually at 50 degrees for 15 to 20 minutes. So, there is a small procedural process by which this insoluble dye can be solubilized. So, that requires addition of two compounds, one is sodium hydroxide and the other one is sodium bisulfite or sodium hydrogen sulphide. It is one and the same thing, and it is slightly warmed up at 50 degrees and it is kept for 15 to 20 minutes, when all of this vat dye can solubilize into the water. In their soluble forms, they behave like direct dyes and hence can be dyed on cotton. So, once it solubilizes, the process of dyeing, that is the capillary action, the impregnation, the adherence of the dye onto the cotton fabric is very facile and is similar to the basic dyeing process that we have learned so far. They remain in the soluble form in the presence of excess of sodium hydrogen sulphide and sodium hydroxide. They should not be present in the dye bath in sufficient quantity. They should be present in the dye bath in sufficient quantity to keep the dye in the soluble form. So, as long as sodium hydroxide and sodium bisulfite is present, it will remain in the soluble form. On exposure to air, this soluble leuco form, leuco means colorless, of the dye gets converted to colored insoluble form of the dye. So, it is back to its original form. So, when the dye powder was taken, it needs to be solubilized by two agents, that is sodium hydroxide and sodium bisulfite at a slightly lukewarm temperature for 15 to 20 minutes, and it remains in the soluble form. Once it is in the soluble form, it acts like any direct dye and it gets impregnated onto the fabric like the normal dyeing process as what would be carried out with any dye. And then once that dyeing process or impregnation or dye uptake has been done, or dye exhaustion from the dye bath seems to be have taken place. Then the fabric is lifted up and it is exposed to air. It is this soluble form which then reacts with the oxygen of the air and it turns the dye into its insoluble form. So, that is the procedure. It is a slightly different procedure from what you have learned so far, but nevertheless it is a very significant procedure. Now, this is how the vat dye is the carbonyl containing group, which is in the leuco form. When it is treated with the sodium hydroxide, it enolizes and it forms like a benzenoid dialcohol, and this is then the leuco-vat acid then when reacts with sodium bisulfite to form the sulfuric ester of the leuco-vat dye, and when we add sodium hydroxide it converts, because this is an acid and so it will form a salt with sodium hydroxide, which is a base. So, these are the various structures. The vat dye has the carbonyl group, the leuco dye which goes into the soluble form is the hydroxy compound which immediately reacts with the sodium bisulfite to form the sulfuric ester of the leuco acid, leuco vat dye, and then finally with sodium hydroxide it forms a salt of the sodium salt of the vat dye. So, this is how it the structures change from one to another and how it solubilizes in the medium. Before the application of vat dyes, they have to be solubilized, that is vatted by adding sodium hydrosulfite and sodium hydroxide. So, it needs to be understood very clearly that in order to convert the vat dye from insoluble form to soluble form, these two reagents are absolutely mandatory. Without the addition of these two, the dye will not solubilize in water, and if it does not solubilize in water, it cannot react with the fabric. These are solubilized vat dye, sulfuric ester of the leuco vat dyes. When they are dissolved, they do not generally produce the same color as their parent vat dyes. So, in the leuco form, it is a very undefined kind of a color, or rather the blue color, suppose if we take the example of indigo, seems to be absolutely faded and it has a yellowish, greenish, undefined fluorescent kind of a color, but once it is exposed back into the air, it gets the blue color on the fabric. So, the blue color which was initially in the dye state is now on the dyed fabric. Like direct dyes, they ionize in water. They have affinity for cotton and cellulosic fibers, and they can be exhausted by addition of common salt to the dye bath. And the best way to exhaust these dyes or to see that maximum dye has been taken up by the fabric, common salt is also added, because it acts like a leveling agent. We had learnt about modifiers and leveling agents and so on. Now, common salt, globase salt, these are all modifiers or leveling agents. So, with the help of the leveling agent, maximum amount of solubilized leuco form of the vat dye enters into the fabric. Now, this is what the sodium salt of the sulfuric ester of the leuco dye, when it is exposed to oxygen, it gets converted into the initial carbonyl insoluble compound, which is the vat dye. But now it is on to the fabric. So, the powder has now gone transferred to the fabric through this insoluble, soluble and insoluble state, or we can say that from vat dye to leuco form and from leuco form to vat dye again. The solution of sodium nitrite and sulfuric acids are sometimes added to, which provides acidic oxidizing conditions which are needed to regenerate the original vat dye. So, sometimes if the procedure has to be enhanced or hastened or has to be carried out in a faster manner, it is possible to do that with the help of addition of sodium nitrite and sulfuric acid, which are nothing but oxidizing agent, and they facilitate this oxidation if the air oxidation or air oxygen is not sufficient. The powder form of the solubilized vat dyes are stable to storage if properly stored away from sunlight and air. Moisture, oxygen and carbon dioxide can be detrimental. So, this is a very stable dye. If it is stored properly, it can be kept for very long times, be it natural dye or be it synthetic vat dye. Their solutions are also stable if properly stored. If they come in contact with acidic fumes or oxygen, a part of the dye is wasted. So, one has to keep in mind that oxygen and moisture should be avoided. Even the paste can be kept. You know, the leucoform paste can be stored, and in many cases some dyers ask for the leucoform directly, because they do not want to go through this process of solubilizing them, and therefore, they ask the suppliers to give the dye not in the powdered insoluble form, but in the soluble leucoform. So, these solutions are also very stable, provided they are not exposed to the air, because if they come in contact with the air, we have seen that the oxidation occurs and it gets converted into the vat dye, that is the insoluble dicarbonyl compound. Vat dye properties. The vat dyes have high color fastness, which is uncommon to other dye classes. On the other hand, vat dyes tend to have poor rubbing fastness, but this can be mitigated with special treatments to the fabric. But although it has good rubbing fastness, but in few cases of the vat dyes, it may have a bit of a problem with the rubbing fastness. Indigo is subject to major croaking, that is rubbing the dye off onto other items unless it is applied carefully. One such example which has poor rubbing fastness or not so appreciably high rubbing fastness is indigo dye, because it rubs off the dye as it is in the insoluble vat form unless it is applied carefully. This means use a weaker dye bath and dipping many times rather than a single strong dipping. So, by doing repeated dyeing, the impregnation is enhanced and the surface dye content is lessened, and therefore, using a weaker dye bath, that means having lesser concentration of the dye in one go, but doing several times dyeing, that is over dyeing or repeated dyeing, and that creates more and more color within the fabric rather than on the surface, because the one which comes on the surface is actually what is rubbed off. So, therefore, that can be mitigated, or that this drawback can be overcome, and the application process only changes in this case, because if the application is done in a good manner, in a manner which will only let the dye be within the fabric and not onto the surface of the fabric, it will avoid the rubbing fastness to be poor. Vat dyeing. After dyeing in a bath containing the vat plus sodium hydrosulfide plus sodium hydroxide, exhaustion of the dye onto the fabric, the dyed material is removed, squeezed and exposed to air. When the leuco-vat dye is converted to insoluble dye form. So, this is what the entire procedure is. We have understood that this is definitely very different from the normal basic dyeing that we covered in the lecture that we covered for basic dyeing material. We also took a look at the typical dyeing material or process for cotton and silk, but this particular process is quite different, and this kind of treatment of the dye powder is necessary for the solubilization of the vat dyes. Sometimes other oxidizing agents like sodium borate, hydrogen peroxide or potassium dichromate may be used to hasten the oxidation. So, as I told you, if the air is not sufficient, if the oxygen in the air is not sufficient, then other oxidizing agents like potassium dichromate or hydrogen peroxide or sodium borate, which are all sources of oxidant, can act as a oxidative material for enhancing the oxidation process of the leuco-vat dye to the vat dye. Now, let me mention here that potassium dichromate is not acting like a mordant in this case, but it is rather acting like an oxidizing agent only. At the end of this treatment, the dyed material is washed, soaked to the boil with a solution of detergent and soda ash for 10 to 15 minutes, again washed and dried. So, that is all the dyeing process is all about when we do vat dyeing. But one has to remember that at what time the leuco must be exposed to the air is a crucial decision, whether the dye exhaustion is complete or not, but there is a flexibility to actually do re-dyeing several times before the final treatment. That is the treatment with washing of detergent and soda ash and so on and so forth. Till then, we can do several dipping, and if we keep the weak solution of the vat dye, that is the leuco form, it is possible to gradually do the extraction or exhaustion of the dye onto the fabric, and that will be acting in a more facile and more advantageous way than just by dipping once. So, it is a common sense that every surface has a capacity to absorb at a particular time, after which it forms an equilibrium. Now, if the equilibrium is reached, then it will go backward forward, that means the dye uptake will not be further facilitated. But if this process, every time there is some equilibrium moving towards the dye uptake, if this is facilitated for 2 to 3 to 4 times, then more and more and more dye will be impregnated on the fabric. So, instead of making just one dip in a strong solution of the vat dye, the other alternative is to make several drips, 2 to 3 to 4 dips in a slightly weaker solution, so that more and more and more dye can be taken up. You can understand in one simple way that suppose if from a weak solution, every time 10 grams of the dye are taken up by the fabric, and we make 5 such dips. So, every time 10 grams will be taken up because of the weak solution, it cannot take up more. So, it will in one go it will take only 10 grams, and thus 10 into 5 is 50 grams will be finally taken up by the fabric, because it gets time to equilibrate and then come back to its normal position, where it is ready to take more and more every subsequent time. Vis-a-vis, if we take an example where we take a stronger solution and make only one single dip, what will happen? It will take up once only 30 grams. So, eventually that one dip has got 30 grams of vat dye on the fabric, whereas the 5 times dip fabric will have 50 grams of dye. Obviously, the color will be brightened in the latter case, and that is the kind of example that I am trying to explain to you. Dipping once is not an advantageous situation, dipping several times is possible, but this should be done before the final treatment or the final wash, soda wash and detergent wash is carried out. All the re-dyeing can be done several times as per the dyer's choice of the color, but once it is exposed, it needs to be, or once it is washed and finally settled, it cannot be re-dyed. Vat dyes. Most vat dyes which require a reducing agent to solubilize them are less suitable than fiber reactive dyes for amateurs. Chemical reactions such as oxidation, reduction, pH control are often necessary. Even the dissolution process necessitates measuring out appropriate quantities of caustic soda and sodium hydrogen sulfide in order to achieve reduction. So, all this is a very tricky process. It is not so simple that you can solubilize the vat dye into the leuco dye just by adding this and that is it. All the measurements have to be done in stoichiometric ratio. Only then all the vat dye will be in the leuco form, because it is equimolar quantities of the sodium hydroxide and sodium bisulfite should be added. The dye is soluble only in its reduced, that is the oxygen free form. The fiber is immersed repeatedly in the oxygen free dye bath, then exposed to the air, whereupon the water soluble reduced form changes color as oxygen turns it to the water insoluble form. So, we saw that how from the sodium salt of the sulfuric acid ester of the leuco dye, it got converted into the dicarbonyl molecule, and that was the insoluble form. Indigo is an example of this dye. It changes from yellow in the dye bath to green and then blue as the air hits it. So, as I told you that when it is in the leuco form, it has a very undefined kind of a greenish yellow color, but once it comes on to the fabric after the exposure to the air, it takes up that bright blue color of the indigo. So, indigo example I am taking again and again because it is a representative of the vat dye, and since you all have seen indigo, it is easy to understand and to correlate what is the dye we are talking about. Details about vat dye classes. Unlike direct dyes which are dyed at the boil, vat dyes are dyed at lower temperature. So, you must know that we do not need heating up to 80 degrees. We had discussed boiling point of water as the temperature, or slightly below the boiling point, that most of the dyes, be it synthetic or natural dye, are actually dyed. But here we work only at very ambient temperature or lukewarm temperature and lower temperatures. According to temperature required for dyeing vat dyes, they are classified as cold dyeing dyes, which is class 2, and for class 2 we just require 20 to 30 degrees or room temperature. Warm dyeing dyes, which is IW class of vat dyes, requires 30 to 40 degrees only of temperature. Normal dyeing dyes, that is IN class of vat dyes, requires 40 to 50 degrees, and special dyeing dyes, that is IK special class, requires the temperature to be something according to what is prescribed on the packet. The dyeing time is usually 45 minutes to 60 minutes. So, that means within an hour the vat dye is already taken up by the fabric. That is why its compatibility, its suitability for cotton dyeing is very advantageous for the dyers. Cold and warm dyeing of the vat dyes. In the case of cold dyeing and warm dyeing dyes, the exhaustion of the dye bath is usually low and hence they need exhausting agents like common salt and Glauber salt to be added to the dye bath after the dyeing has proceeded at the appropriate temperature for some time. So, these kind of modifiers, these kind of dye enhancers are to be added, because there is no other agency that can speeden up the, and they also act like a leveling agent or a balancing agent and cause evenness in the dye uptake. Otherwise, what will happen, because these are basically electrolytes. Sodium chloride common salt is NaCl, Na plus Cl minus. Glauber salt is sodium sulphate, which is Na2 plus SO4 minus minus. So, these are nothing but electrolytes, and the presence of electrolyte actually creates a kind of a a situation where the equilibrium is achieved in a more facile manner. On the other hand, the rate of dyeing of the normal dyes is so fast at 50 degrees that their dyeing has to be retarded by the retarding agents, also called as leveling agents. So, sometimes this dye uptake is very fast. Even that is not very good, because it will cause unevenness, because the motion of the fabric may not match with the speed of the uptake. So, in some places the dye uptake will be more, and in the other places the dye uptake will be poor. So, even that situation is not a good situation or a happy situation. So, there, in order to slow down the process of the dye uptake, some leveling agents like dispersol VL, Tinigal CV are added, so that the uptake is slow and it matches with the motion of the dyeing. Because if this is not compatible, if they are not of the same order, there will be patchiness that will occur on the dyed fabric. Some trade names of the dyed fabric are, these are all commercial synthetic vat dyes. We already know indigo, acetin and cum and such dyes are from the natural class of dyes, but amaranthine, benzanthrene, chalconoid, carbinthrene, indanthrene, nevidone, nevinone, solanthrene, supranthene, these are different types of vat dyes which are synthetically produced, and they have been in use in the dyeing industry for a very long time. Dyeing with indigo. Since dyeing is carried out at low temperature, a good preliminary scouring is necessary to make the cotton easily permeable. The dye vessel is filled with soft water and dissolved oxygen is removed by the addition of 1 ounce or 100 gallons of sodium hydrosulfide. So, in order to keep the situation as a reducting atmosphere, sodium hydrogen sulfide must be added first. The required amount of the reduced indigo is added from the stock vat, and the suits are immersed in the dye liquor at 20 to 25 degrees and agitated for 15 minutes. It is important that a machine or a method of handling should be used in which the goods are totally immersed to prevent premature oxidation from taking out the excess which are exposed to the air. At the end of 15 minutes, the goods are taken out, the excess liquor is squeezed back, and the leuco compounds are oxidized by exposure to air. The first dip will only give a pale blue, and the sequence of operation is repeated 2, 3, 4 times until necessary depth of the shade is obtained. So, we just took that example in much detail to make you understand that this is the entire process of dyeing with indigo, that be it natural indigo, be it synthetic indigo. Structurally more or less they are the same, we have looked into that, and indigoid class of dyes we have studied in details. And in this case, first the water that is to be prepared for dissolving this vat dye, indigo dye, must have sodium hydrogen sulfide, so that it is under the reduction or reduced state or has a source of hydrogen. And to that, when the vat dye is added, it gets converted into the leuco dye, and then the fabric is slowly immersed into it. After 15-20 minutes, it is felt that the dye uptake must have taken place. One thing that has to be kept in mind, that all along the fabric should be within the surface of the dye solution or below the surface. If it rises above the surface, which is a normal tendency because fabrics are lighter in density than the solution, what will happen, the portion which has come up will get exposed to the air and will get into blue form, and this will cause patchiness. So, in order to avoid patchiness, all along when the fabric is in the solution, it must be completely immersed in the solution and must be rotated all the while. And when it is taken out, all the excess dye solution should be squeezed out, and that should not remain, and then finally it is kind of checked whether it is the desired color or not. Otherwise 2, 3, 4, 5 dips can be carried out before the final treatment on washing of the detergent and soda wash treatment is done. Cellulose has not great affinity for leuco compounds of indigo, and heavy shades must therefore be built up by successive immersion, because an excessive concentration of the dye in the liquor leads to unsatisfactory rubbing fastness. We just took that into consideration. Exhaustion can improve by the addition of 5 to 40% of common salt, that is when an electrolyte is added as a leveling agent. According to the depth of the shade and the liquor ratio, deep shades are built up by successive in a series of liquor of increasing indigo, and thus the first bath might, for example, have 0.3 gram per liter of reduced indigo, and concentration increase until in the sixth it is 3 to 4 grams. So, initially weaker solutions are used, and then finally the concentration of the indigo solution in the second and the third and the subsequent are enhanced. A counter flow system may be used, the first bath being certified from the second and the so on, and every addition of the reduced indigo can be increased subsequently. When the dye goods have been exposed to air for large enough for oxidation to be complete, they are seconded to remove the insoluble indigo blue deposited on the surface of the fibers. So, then finally, it is exposed to the oxidation part, and then it is actually confirmed that the fabric is dyed.